Hello everyone. I will demonstrate you virus cell fusion dynamics, or it's called cell membrane fusion dynamics, in an interesting way. It's called drop coalescence at the droplet and with the bath. You can think the droplet as the virus. This droplet contains microparticles. You can think the microparticles as RNA, and the water bath you can think as the cell. So now this drop coalescence itself is very complex, and it, depending on different parameters, it can have different kind of outcome. And having said that, the cell in when it becomes in the it is in the cell, these things also very complex because there are a lot of proteins, and the cell is more viscous than this. But I wanted to pay attention. The key point here is that the role of membrane tension difference between the bath and the droplet. So I added surfactant here in this solution to make the surface tension lower, so that the surface tension difference becomes higher for this droplet and the liquid bath. I didn't add anything here, it's just water, and the microparticle contains the droplet contains microparticle and water, so surface tension, both of them are very close. So for this one, there is a surface tension difference significantly. There is not enough surface tension difference. And if you look at the equation here, you can look at the all equation here. We actually published an article of the viscous resistance of drop coalescence. So basically what happens at the early stage of coalescence, like when you cannot see here, like maybe in atomic, not atomic scale, at the nanoscale. So at that very moment, when there is a surface tension difference, from here the sigma d represents drop and sigma b represents bath. So the sigma b is lower than the sigma d. That means this is a positive value. At that very moment, what happens is that it doesn't create enough resistance to the flow, and then that will lead to higher penetration depth. But when this membrane tension difference is very equal, in that case the penetration depth will be lower. Okay, let's see the video first. You see, the moment it touch, the droplet goes all the way down. So it travels very far, right? If I see the right video, once it touches it doesn't go far away. So exactly same thing can happen in the cell. When there is a cell membrane tension difference, then the viral RNA will travel further away from the cell membrane. But when the membrane tension difference is not significant, or maybe very equal, in that case RNA will go inside the cell, but the RNA will reside next to the cell membrane. And it is very well known phenomena in colloidal science that if something, especially the micro level or nanoscale something, reside next to the membrane or cell or anything, then there is a hydrodynamic interaction. So in micro scale, things are not really try to move. Things are not, it's not easy to move things around. So in that case, for the right one, in cell membrane fusion process, the RNA will reside next to the cell membrane, and the ribosome or the cell replication machinery will not be able to reach the cell membrane, the viral RNA, where it is next to the cell membrane. In that case, the RNA will be there for extended period of time, and other protein can destroy it. But for this one, the left one, when RNA goes inside the cell, it can easily picked up by the cell replication machinery and can make it double, twice, thrice. So that's the way virus replicates faster in your body. Now, when this can happen, it can happen for many reasons. For example, if the cell membrane, there is something on the cell membrane, and that can changes membrane tension, or say pH, the medium where these things happening. The pH can play a role here too, or the temperature. And to my study suggests the temperature plays is really a big role here. So when temperature drops, the virus shell tries to shrink, but at some point it cannot shrink anymore. So lipid kind of organized on its surface, like in the membrane, and the tension develops. So when virus membrane tension develops, in that case, this kind of membrane tension difference happens and higher penetration can happen. So temperature is one of the reasons. That's why cold and dry air causing much more issue. There could have many other reasons, like as I said, pH could be another reason, or maybe cholesterol could be another reason. Anything that can changes the surface tension differences, membrane tension differences, and at critical point the penetration depth will be higher and people will be sick much faster. So that's why I always suggest that try to keep your nasal airway warm as possible. Like sometimes, like if it is happening in the body temperature, the favorable replication will not be happening, because will not happen, because there are two ways virus can goes into the cell. Another call is endosome fusion and cell membrane fusion. Endosome fusion is two-step process, but cell membrane fusion is a one-step process. That means it can make copies much faster. So if you can protect your nasal airway and you can make your nasal airway warm, then you will most likely not gonna be sick if you catch the virus. And also, if you have the virus in your body and the blood, through the blood stream, it can go everywhere. So under your skin, it can be also at lower temperature. So in that case, you need to be in a hot and humid kind of environment. For example, sauna bathing can be helpful. So, but as long as you don't have the virus, using mask or maybe inhaling warm air can be helpful. And still, as I said, some people will get the virus because of some kind of diseases. Maybe their membrane tension can be different. And also, I wonder, vaccine can play a role here too, because when you are taking vaccine, the spike protein goes to the cell membrane, and that can also change the cell membrane tension, and that can make some kind of differences in cell membrane tension properties. So yeah, I mean, a lot of research need to be done to figure this out, but the membrane tension difference can be a very essential thing, or maybe the first thing to do. So we published an article previously, and in the description below I'll share the link here. And this experiment, this simple demonstration, I did in my current with my supervisor, Dr. Sambita Das, and yeah, I'm sharing this with her courtesy. And yeah, we have been doing a lot of interesting things, but yeah, I just wanted to share this video to convince you that the cold and dry air can make you sick. And as if you are in United States, and if the temperature is outside getting hot, and if you live in indoor AC, you can get more sick. So, and that's what is happening around US, especially this week. I expect that it will obviously cross the 50,000 cases within a few days. Perhaps next week we will see more than 100,000 cases. So that's why I couldn't resist to share this. I hope this is gonna be helpful. And yeah, if you want to discuss more, I'll be more than happy to discuss about this. Thank you very much. I appreciate your attention.